Factor completely by hand with algebra. So here is your expression. And the first thing you always do with a factoring problem is always factor out the greatest common factor first. That always helps and never hurts. Start by factoring out any common number and variables you see. So I saw that 3 divided into 12, 63, and 54. How did I see that? I used the divisibility rule for 3. 3 divides 12 because the sum of the digits of 12, 1 plus 2, equals 3, and 3 divides into 3 evenly. For the 54, 3 divides 54 because the sum of the digits of 54, 5 plus 4, equals 9, and 3 divides 9. Then I factored out the 3, and I would continue on if there was anything else in common. But there's no variables in common to all 3, and there's no more numbers in common in all 3. So we're stuck with this, and there's a lot of choices there. Alright, so what you do next is come down here. You list the factors of the first term coefficient and the last term. And by that I mean there's a 4 here, so you say, well, I could have a 1, 4 to make that up, 1 times 4, or a 2 times 2, and that's the only combos that I could have. Because 4 times 1 for the front, I always just put the large one here. It's not really different than 1, 4. But this order on the 18, 1, 18, 2, 9, and 3, 6, those orders all matter. You can go 18, 1, 9, 2, 6, 3. So I use binomial pair templates, like this one, to rule out each of the possible first term products. I'm going to go with 4x and x first, because that's 1 times 4 is 4. The out and in products must combine to reach the middle term, or else you have to move on to another first term template. Okay, so let's try these in here. 1 and 18. Put it in there lightly. Check the out and in. The out is 72 and the in is 1. There's no way that reaches by adding or subtracting to 21, so that's out. So 118 is out. How about 18 and 1? 18, 1. 4 and 18. Let's make that a little better so you can see. 4 and 18 makes it to 22, not 21. So that's out. So we've now exhausted that pair is out. 2 and 9. 2 and 9. 36 and 2. That doesn't make it to 21 by adding or subtracting. So how about 9 and 2? 8 on the out and 9 on the in is only 17. That doesn't make it to 21. So 9 and 2 is out. Now we're down to 3 and 6. 3, 6. 24 and 3. That makes it 21, but maybe the sign works and maybe it doesn't. So now you got to try the signs. So it comes out negative 18, so the signs are opposite, and the middle turns positive. So the big one, the big product, has to get the positive, and the other one has to get the minus. Negative 24, 24 on the out, minus 3 is 21. So we found it. Now, we found the factorization, but if that didn't work, the 4 and the 1, we would have went on to the 2 and 2. So you exhaust all these and then you go on to the 2 and 2, and that works. This is called very intelligent guess and check method. It really reminds you of the FOIL method There's other methods out there, and you can use those certainly, but this one is the one that shows you what's really going on, and you get practice with factors, factoring, common factors. It really is a good workout. Another thing is, don't forget this 3. A lot of times students forget to put the factored out GCF down in the final answer. Carry it through. No matter if you had to keep on going, you'd have the 3 there. You'd keep on going with the greatest common factor there on every step. Don't just do the factoring step alone without the 3, because you're going to miss it. Of course, the ultimate way to be safe is to multiply back the final answer and see if you get back to the original. And so let's just do that. First is 4x squared. Out is plus 24x. Ins is minus 3x. And then out last is minus 18. That's 4x squared plus 21x minus 18. And of course it works because that's how we decided the 6 and the 3. Then multiply the 3 back in, 12x squared plus 63x minus 54. And does that check out with the original? Yes, it does. But of course the answer is this. This is the answer to the factoring problem. This is just a check.